Hi everyone, in today's lesson we're going to graph y equals a cos bx and y equals a sine bx. So we're graphing two basic trig functions without vertical shifts. So let's try our first example. So example number one, I want us to graph y equals, or f of x equals 3 cos 2x. So, as we did the other day, the ACPI is going to be very helpful. So A, C, P, and I. A is the absolute value of the number in front. So the absolute value of 3 will give us our amplitude. So the absolute value of 3 is 3. Cycles or frequency is the number in front of the x. So in this case, 2. Period was defined as 2 pi over b, where b is the number of cycles. So since cycles are 2 pi over 2 will reduce to pi. And then our interval is defined as period over 4. So in this case, period is pi. And if we divide it by 4, we get pi over 4. So this interval was something that we really didn't discuss, and it's really important now because we need to be able to set up our XY axis to graph this. Now, when I graph this, I should tell you what I want, what domain to graph it over. So I'm always going to ask you to graph between 0 and 2 pi, or in other words, 0 and 360. I could change that, but for now, let's say 0 and 2 pi. So I'm going to draw a nice XY axis on our page. And this interval that we speak of, pi over 4, is what we're going to label our x-axis with. So we're going to count. So this interval is really what we count by. So if I said count by twos, you'd probably be able to tell me 2, 4, 6, 8. If I say count by fives, you'd be able to tell me 5, 10, 15, 20. If we count by halves, you would say 1/2, 1, 1.5, 2. So if I say count by fourths or 1/4 pi, all we're going to do is count by fourths. So the way we do that is we'll call this 1/4, so 1/4 pi or pi over 4. Then we can say 2/4 pi, 3/4 pi, and then 4/4 pi. But notice some of these can be reduced. So 2/4 is the same thing as 1/2 pi, and 4/4 is the same as 1 pi, right? 4 divided by 4 is 1. So we can keep going because I want to count up to 2 pi. So we went to 1/4 pi, 2/4, 3/4, 4/4. Then we can keep going. So 5/4 pi. Then we can go 6/4 pi, 7/4 pi, and then 8/4 pi. Now, 8/4 is a good place to stop because 8 divided by 4 is in fact 2. So if you want to simplify these, you can, but you don't have to. You just have to know to stop here at 8/4, which is 2 pi. And then the last thing we need to know is that our amplitude is 3. So that's the max and min values, right? That's how high the graph is going to go. So I'm going to label this here as 1, 2, 3. I'm picking a scale so that I can spread this out a little bit. So -1, -2, and then we'll make this -3. So we know that we're graphing a cosine curve. So we know that cosine curves start at the maximum. So in the back of your head, in order to graph this, you need to have this picture of a positive cos graph. This is what a positive cos graph looks like. So our first tick mark, we are drawing this spot up here. Then we go to the midline. Then we go down to the minimum, up to the midline, and then back up to our maximum. And then we're just following this pattern. So then we're going to go down, down, up, up, and then connect. So we're making positive cosine graph here, and here, and here. So let's see if what we did makes sense. Period is how long it takes the graph to complete one cycle. Period is pi. So let's highlight it out and see. Here is the beginning of the cycle, goes up and down. That's one cycle. and it took 4 pi over 4, which reduces to pi. So period is correct. Cycles is how many complete rotations you see between 0 and 2 pi. So let's trace again now, starting from the beginning. 1 cycle, 2 cycles in 8 pi over 4, which reduces to 2 pi. So my cycles here are 2. I see 2 cycles between 0 and 2 pi. And that's it. Looks like we have everything we need. Here is our graph of 3 cos 2x. All right, let's try another one. Okay, I'd like to do now a sine curve. So example number 2, f of x equals negative 2 sine pi over 2 x. So again, we need our a, our c, our p, and our I. So the absolute value of the number in front, the absolute value of negative 2, will be our amplitude. So the absolute value of negative 2 is 2. Cycles is the number in front of the x, which happens to be here, is pi over 2. Period is defined as 2 pi over b, where b is the number of cycles. So we're going to plug in b to be pi over 2. So we're going to do 2 pi divided by pi over 2. And remember, when we have fractions, we're going to keep, change, flip when we divide them. So we're going to keep the 2 pi. Let's make it 2 pi over 1. Change the division to multiplication and flip that pi over 2 to be 2 over pi. And then we multiply our fractions straight across, and we get 4 pi over 4 pi over pi, where the pi's will cancel, and my period will be 4. Interval is defined as period over 4. So my period is 4 divided by 4 is 1. So that is what we are counting by. So let's draw our xy axis here and here. And this I want you to graph. I should tell you what to graph. So let's graph 1 cycle. So the other one I said graph from 0 to 2 pi. This one I'm giving you specific directions to graph 1 cycle. So this interval is what we count by. And if we want 1 cycle, we know that the period is 1 cycle. So we need to go up to 4, counting by ones. So this one's actually much easier than the first one. So we're going to count by ones. So we need 1, 2, 3, and 4. Notice how I'm spreading it out a little bit just so that it looks a little bit neater. My amplitude is 2, which means I have to go up 2 and down 2. I'm going to stretch it out a little bit. I'll actually call this first one 1. Sorry about that. And we'll call the second one 2. I went up by 3s, so I'll have to go down by 3s. You can pick whatever scale you'd like, but that's the scale that I'm choosing. And this time we want to graph a negative sine curve. So you need to have in mind that a negative sine curve starts at the midline and goes down, up, down. So this is our picture that we need to draw. So our first tick mark is going to be at the midline, which in this case is the origin. And we're going to go down first to the minimum, then up to the midline, up to the maximum, and then back down to our minimum. Our midline, and connect. And that is our negative sine graph. So here's 2 examples. The first one was a cosine curve, and where our interval that we counted by was in terms of pi. And here is a negative sine graph, and the interval that we're counting by happens to be whole numbers. And I asked you to graph 1 cycle. So take a look at these 2 examples, jot down any questions that you might have, and then don't forget to ask us in class tomorrow. All right, have a good night.